Thanks. I'll just give you guys a real quick background. First, I'm kind of new to Google, so they still call me a noogler. Okay. I was brought in primarily as an educator, so to both educate both internally and externally people in AI. Okay. As far as my background, I have a graduate degree in AI back in the dinosaur days. I was a principal researcher for Sharp Corporation in Japan for about 20 years. At times I ran the research lab. My background really was as an imaging scientist. I have 115 US issued patents based on imaging work I've done. I've worked on everything from telepresence, augmented reality, digital signage, and autonomous vehicles. Okay. So today what I'm going to do is I'm going to talk about AutoML. You hear a lot about it, okay? But I'm actually going to talk about it from the product side, okay? There's sort of a distinction. A lot of the talk about AutoML is really about the research side, okay? And companies are now releasing products, okay? And so there's sort of a differential between here's the product and here's the research. So I'm going to talk about the product and actually show you how to use it today as a software engineer, not as a data scientist. Okay. And so when I think about these two tools, I just don't just think solely of AutoML. It kind of goes from a software engineering perspective. It's combined with what we call AI as a service. So Google provides a number of APIs that you can call, think of them like canned APIs that would do image classification, natural language translation, and so forth. Where AutoML comes in, it comes in and takes that, and we'll go into it more, and customizes it to your particular application. So it's really something to think of to build on top. So what I'm not going to be covering is we're not going to talk any math, we're not going to talk any code here. We're going to talk about building models. Okay. So what's the need for this type of product? Okay, so here's just some marketing data. McKinsey is a global marketing company, well respected. They came out with a report this year, and they estimated worldwide there's 100,000 qualified data scientists. Okay. About the same time, Lincoln every year does its workforce report, and it estimated just in the USA alone, there's a shortage of 151,000 data scientists. That is what's in demand and not being fulfilled. Okay. IDC, a global marketing company, estimates the number of developers worldwide is at 22.3 million. So you can see there's a huge differential between the workforce and the number of people qualified and the growth in demand. So in these situations, demand, here when you have demand outstripping supply, demand ends up driving the market, and what we're finding is big companies are now asking those companies providing AI products to not just focus on data scientists, but start delivering products that can be used by software developers today without making them a data scientist. Okay? So, in some ways what that means is products that aren't dependent on math or knowing how to do symbolic programming or or doing things in a procedural style. Okay? Instead, products that utilize imperative programming, heavy emphasis on reuse, and today we all use APIs and microservices. Okay, so this is kind of an ecosystem that's being developed at Google for software developers. It's ongoing, okay. I like to make this little caveat here. As a Google employee, I'm told I can only talk about what's been announced. So if you have any question about what's next or the future, I just can't answer it. There's my little humorous response. I just can't confirm or deny the presence of AI. Okay. So in the remainder of this presentation, I will cover high-level concepts of both our AI as a service and our AutoML, go into some detail, and then I'm going to do some real-world implementations. But in the latter what I'm not going to do is I'm not going to show you anything to do with mints, flowers, cats, dogs, or clouds. We've all seen that. It's kind of old school. I'm going to talk about stuff that you actually do today in the workplace. Okay, so I'll start with AI as a service. Okay, so we have a vision API that allows you to do image classification. That's basically taking an image and saying, what is it? Object detection is saying where in the image something is. Okay. Video intelligence. So as you have a video and being able to do the image classification, the object detection frame by frame in the video. And then text extraction if there is actual text in your image or video, such as a sign. Okay. Our natural language processing API allows you to do document classification. Upload a document, and it tells you what it's about. Okay. Sentiment analysis, basically extracting the opinion or attitude of the person who wrote that. Okay. And then named entity recognition. So recognizing, names, places, etc. Translate, that basically gives you language translation. So, English to German, Japanese to English, so forth. Okay. And we also provide, the API is provided in real time as a streaming service. Speech to text, basically what did they say? Okay. It recognizes, it's trained in 120 different languages now. And again, it also provides it in real time. You can do real-time transcription. So, going into a little detail, the way AI as a service works is Google has pre-trained models, okay? And assuming like this, I guess I have to point out here. So over here, assume that blue area is like your application. You would just make an API call to our cloud service, and it comes back with a response. So in that API call, you might be uploading an image, a video, a text, or an audio object. And it's going to come back with some kind of information about it, for example, like a classification. Okay. What our AutoML does is it says, hey, if our system doesn't classify, let's say for example, take classification, what you're looking for, you got a more finer problem than our pre-trained model is, you can customize our vision API. So AutoML basically, and I'll go into more detail, does transfer learning, taking the pre-trained model, adding in your data set, and then, how would I say, retrains that model to include your data set. So really what you have is you have a sort of an aggregation of the pre-trained model, which is the AI as a service, and your customized model. Okay, so I'll go back to the Vision API. So here, it's a pre-trained model. It's powered by what we call at Google best-in-class convolutional neural networks. These were all originally developed, and you probably all have heard of ImageNet. Okay, so these are the kind of models that won ImageNet, but have been refined even more since. Okay, they've been, Google has all the images in the world. I don't think that surprises anybody, so it's been trained on mega millions of labeled images. By the way, if you want to figure out how they label all those images, you ever notice when you get that annoying CAPTCHA and you're supposed to click in which boxes has the sign or which one has the car and all that? You're labeling images for them. Okay, about half of those images on that CAPTCHA are known, and yeah, you have to hit those right. The other ones, it doesn't know. It doesn't care what you click. You're actually providing Google, you could say, as pre-labeling. But the end result is mega millions of labeled images, and with that, they've been able to train this massive pre-trained model to recognize 20,000 different types of objects, and that's what they call a label. Okay? We also refer to it as classification, and I just gave a little simple case. You have an app here. You put up this picture of I think that is a a Maine Coon cat, and it would come back, not only would it tell you it has 97% confidence that that's a cat, it would tell me I had 87% confidence that the breed is Maine Coon. Okay, and I tried it myself before I ran this, so I know those two numbers are right. Okay, object detection goes a little further. So let's take this picture of this child on the bicycle. It tells you of the different objects in the image and where they're located. So you can see in the red box is showing that's a bicycle and where the bicycle is. And then in the blue box up there, you can see that's saying that's a person, or more specifically, a girl. Okay. And then finally, at the top right up there, recognizing that there's a helmet. And so that's object detection. Okay. Video intelligence, I just kind of handed this. It's sort of a frame-by-frame analysis. In the hypothetical case of you have a camera on your porch, okay, or ring.com, okay. So in one frame, you see the red box is just showing this is a bounding box, just showing that there's a porch there. There's another little bounding box that's labeled as a package, you know. A few frames later, it's pretty much the same thing, but now there's another bounding box there with a label that says it's a person. A few frames later, suddenly the only bounding box is a porch. There's no person, no package. You figure out the rest.
So they stole the package.
Yes! Okay. So for our text extraction, okay, so you could upload a picture of a sign. For example, this is a typical for sale sign at a home. Yeah, you could just, take a picture and look at it later to get the, the phone number of the realtor and all that. But you could also have some kind of automated application that just extracts out the text and puts it in your calendar or something like that. Okay, and this is all the stuff that you don't need to do any AI for. These are just APIs like any other API. Okay, so when to use AutoML? Well, really, you use it when it doesn't quite get something right relative to your application. So I took some silly cat-like pictures here that really you wouldn't classify as a cat. So this one way over here on the left I found on a website that sold Halloween costumes for pets. So this little cat here, it's got a lion mane costume on it, and I was curious, what would it get classified? Well, Garfield is supposedly a cat, but it's really a well-known cartoon character, and Cholo here is similar. It's not a cartoon figure, but an animated movie character. So I was kind of curious. These don't really, they're cats in some sense, but they're not really what we mean by cats. So let's see what happens. So I uploaded one, and so the cute little guy here, the first thing it predicted with the highest confidence was it was a human face. I said, yeah, that's a misclassification. That's not going to work for me. Yeah, that one surprised me. Garfield wasn't so bad. I thought it was a cat. But, Garfield is a characterized orange tabby. It says it's a red fox there. And, it's really a cartoon, not a stuffed toy. Okay, and Cholo, I think that's how you say this, kid's one here. Nowhere in the classification here does it give me any clue that, quote, it's a character cat or that it's even an animated cat. Okay. So you have, differences of incorrect classification and incomplete classification. Okay. So let's look at how AutoML Vision can be used to customize this. Okay. So in the original trained model, the one that Google has that recognizes the 20,000 different labels, different types of things, it was trained anywhere between 1,000 to 10,000 images per label times 20,000. It's a massive amount of training. Okay. For something you're doing that's much more stripped down, you don't want to go to that level.
Okay, so in transfer learning, we basically take that model, which is really a set of layers, and those layers have weights and biases, and we transfer it over to a new model, and we keep the entire top of the model, and we just retrain the bottom. So it's very quick, okay? And you don't need as much data to do it. Typically, what took to train an entire model, 1,000 to 10,000 images per label, only takes as little as 10 to 100 images per label to train using this method. And of course, there's a dramatic reduction in compute time. The other thing AutoML does, you can get a separate model, but it's actually set up to fuse with its online service. So if I'm an account, and of course my application has my account key, and I call the Vision API, the custom model that I've created for my application gets fused with it. Okay, so you don't have to create a whole new thing. You just continue to use the existing Vision API. So I made an example here of, let's say you had an existing home security service. So you have your application here on the left. You have some kind of sensors there, like window door sensors, right? It's hooked up to Wi-Fi. Sensor goes off, sends an alarm to a service up in the cloud, and the service calls dispatch to the police. That's your existing application. And now you want to add some AI to it. So we decide we're going to add a camera, and we want to use some video intelligence. Okay. So in this case, what would happen if we just used our Vision API, we could take the data from the camera, call the video intelligence, and it could tell us in a time sequence what it's seeing in the frames, the object detection. Okay. But let's go a little bit further, and let's come up with some, you're a developer, and this is just a REST API call. And so we're going to just write some simple code here from a developer point of view. We have some loop that's continuously calling the video intelligence API call. Comes back with what's in the picture, right? And we're going to look if what's in the picture is a person or a package. And if so, we're going to raise an event. That's kind of a common programming thing, right? Okay, and then we have an event handler here. Okay, well, first we start off by saying package is false, person is false, start up our loop. And then our event handler, so every time it gets called, we look at the labels that came from that frame. We're keeping some state here with package and person. So if the new notification tells us there's a package in the labels, we set package to true. If there's a person in the labels, we set it to true. And then we kind of look at the state. If we say there's no package in the label and no person in the labels, but package and person was true, somebody just walked away with our package, so send an alarm. So I'm just kind of showing you, how easy it really is to use AI as a service. It's still normal software development. And with AutoML, you can further customize things where you feel that API isn't quite matching your specific application needs. So we'll just look a little bit here at the natural language API. It does a lot of things. The thing most people first come to mind, of course, is rating sentiment on a per sentence basis. So I uploaded some text here. I'm probably not going to read the text, but this was out of an insurance claim demand letter. There's sort of an intro, the person. So that's a +2. Then, later on in there's sort of a complaint. I was not injured, but my car suffered a fair amount of damage, which despite repeated phone calls, Northern Insurance has so far refused to pay. So you can see it's classified that with a fairly negative sentiment. Later in there, in the demand letter, the person writes the Jenkins driver obviously negligent. So there it shows even a higher level of negative sentiment. Why is this important? I mean, you could read this document, but this say you got documents, tons of documents, and each one is really long. Really what you're interested in two things. The overall sentiment of the document, where you're going to sort it, send it, right? And the parts of the document that are important. Okay? So, if this document really is negative, the parts I'm interested in is the stuff that's actually really negative in the document. And auto find those parts and pull them out and possibly put them into some summary. Okay. And you can do that just with the API. You don't need to build a model. Okay. Other things the natural language API does is it locates entity. Okay. So I took that same insurance claim form. Again, I'm auto sorting, right? So it identified 4 entities in there: location, event, person, location. Chestnut Street. Okay, that kind of helps me sort. Like I know that this has something to do with Wisconsin. All right. Okay. Or Waukesha, can't say it, Wisconsin. The event, collision, another event, incident. Already giving me information, context of the document, and then person, driver. Okay, so you can probably imagine it wouldn't be too hard to write a sorting algorithm to deal with this type of information coming through. You don't have to write a model. Okay, so when to use auto NLP? Well, let's try these documents with NLP, and what would you get? So I took an insurance claim form, okay, and it came back finance insurance. That's pretty good. It's not quite as refined as I would like. I took an insurance letter, again, finance insurance. Course, it's got it correctly, coarsely, but not exactly what I would like. I'm thinking this is a big claims package. So another document was the auto repair estimate. That wasn't too bad. It came back. Autos, vehicle, parts, service, auto repair and maintenance. Okay. But then I took the invoice and it came back the same. So I couldn't distinguish between the estimate and the invoice. Okay. And presumably instead of renting a car, this person submitted some kind of rideshare receipt. Welcome to the modern world, right? Okay, and I came back travel. Okay, so I would have found in this case for sorting, if I was an insurance giant, the categories are a little too coarse. So I like where it's going, but I want to train it a little bit more specific for my finer categories. Okay, so again, Google has, with its massive efforts, has, a giant pre-trained model that covers 700 categories for NLP. You saw a few of those categories. It's the same thing. When you use AutoML, you're transferring that pre-trained model and you're only retraining the bottom layer. And again, instead of needing millions of examples, many times you can do it with as little as 10 to 100 additional documents to get this finer level training tuned to just your needs. Okay? So here, it's just I've used that claim sorting one. So in a traditional application, pre-AI, you have all these electronic scan documents. There's some person manually reading them and using the application to sort them, and they're uploaded to some service based on category. Now we take that person out, we take that NLP model, the one that we even further customized. API calls are made to the NLP analysis, and based on its classifications, it's just auto classified and uploaded to the service. And I should check my time here. Oh, that was relatively fast. So that's actually the end of my my presentation. So you guys have plenty of time to ask me any questions. Yeah.
I'm curious if you're like a company with a bunch of insurance claims data,
Yeah.
and you want to do this transfer of learning to have a more specific NLP thing, that data might be valuable, so does that now belong to Google in some sense?
No, it's your data.
So it's completely, okay.
I mean, you have two choices. Okay.
What if it's sensitive, like if it's HIPAA?
Well, what we, HIPAA is different because you
Sure.
could only do this then on a, Google does have cloud services that have been partitioned off and certified as HIPAA compliant, but you cannot do HIPAA data on an arbitrary cloud service in violation of the law.
But even if it's just valuable data. maybe
Okay,
not.
so that's what we call, what do you call it? Is it depersonalization or it's?
Yeah.
Sure.
De-identify.
Oh, de-identification. Thank you. Yes, there are de-identification services. Again, those have been trained via neural networks to recognize in documents names, social security numbers, telephone numbers, that type of stuff, and remove them.
But even beyond like personal violations, it's just your company has spent the time gathering all this data. And they
Well,
might
you
be-
remember,
they might
we're
be-
training your customized model,
Right.
which is federated off from our main model. None of your data or nothing you learn gets transferred back to our model.
I see.
It's
Thank you.
federated off.
Got it.
Anybody else have a question?
I guess.
So, yeah. Can you extend the capabilities of some of this? Like, if in the instance where you had the text where you found a for sale sign and pulled out OCR style.
Right.
Say now I wanted to know the bounding box of where that chunk of text.
Yeah,
where
okay,
each
yeah.
letter
So,
is.
so when you use the Vision API, there are several parameters you can pass for saying how much, analysis do you want. So you can tell it to just tell me overall what you think the image is. Or you can go the next level, break it down by objects and tell me which each object is. And then, or if an object contains text in it, give me the text. So in this case, you're going to make a call saying, I want object detection and text extraction.
Do you pay more for?
Yeah, you pay more. Yep.
So I went onto the Google site and played with the AutoML for the computer vision, but I didn't see, at least it wasn't publicly available yet, a place for just sort of raw textual machine learning. So not natural language processing, that, for example, building a custom machine learning model for forecasting using AutoML.
Oh yeah. Like I said, I can neither confirm nor deny the presence of AI.
Can you wink or something?
Well, what I can tell you is, and this is what's always well known, Google's product releases are coordinated with its major conferences.
Okay. When's the next major?
Next one is Google Next in April.
April. Got it.
So, anybody else have any question?
Is there a transfer of learning for object detection as well as
Well,
classification?
Object detection itself is not really a transfer learning thing, but you would use it. So, object detection, if you're familiar with it with like single shot or you look only once and that, is having really good algorithms to come up with region proposals where in this picture there's a distinctive object. Regardless of how that comes out, and finally it says, here's what we think are the objects. Each one of those regions is then put through a classifier. And that classifier is already trained.
I see.
Yeah, we are evaluating this ratio of AutoML, and
Right.
one thing we noticed that you cannot export the model out. The only way.
Yeah, I
you
can
use
neither
model
confirm
is
or
to-
deny.
So I'm just asking I'm just thinking, any reason behind that?
Okay. It's a big company. And everybody in big companies and with all the hype, they rush products out, right? Okay, there's a hard deadline because it's aligned with a conference. Okay, And with anything like that, and it comes to crunch time, you really got three choices. You can drop features, you can delay the release, or you can throw more bodies at it, okay? Well, because they release things always at conference time, you can't delay the product. Okay, so some of the features they may have wanted on that release don't actually make it and then get rolled over to the next release. But that's typical in any large corporation. Yeah.
If you were evaluating the AutoML solutions for Google, Microsoft, and Amazon SageMaker, what's the differentiator for Google from your perspective?
I think from Google, it's really the focus or shift the focus because it's more recent to just reposition the whole product as a software engineering product, not position it anymore as a data science. I mean, I can't say much, but this is actually all true for all three vendors. All three of them promoted this as a premium product for data scientists. None of them are hitting their revenue forecasts. So the end result is realizing wrong audience.
What about handling information dense text, where I'm not looking for sentiment, but more like logic, maybe dense legal language?
Yeah, well, I think that's a combination of more advanced entity detection. So I think with every release, you're going to see advances in that. And then some of your own, using AutoML to train it with your own specific legal.
I've had troubles with part numbers. So like because part number catalogs are kind of changing, and you might have part numbers appearing in text, and I have trouble getting at that. Is this an option for me?
Yeah, that's one option. Okay. I know that.
Even though it's never seen this part number before.
Right. What I would recommend, because it probably noted, some kind of numbers it's going to recognize because when you do entity, the old school of doing entity recognition was using like a regular expression. So you had a pattern, right? Whenever you saw that pattern, you said that was it. And then you always had cases you missed, so you kept modifying the pattern, get higher and higher, what you call it, true positives. But then you start recognizing things that aren't. It's a back and forth battle. Okay. What happens in neural networks is they learn the context around the thing. So they know the pattern, but they learn the context, so you're only getting true positives. You can filter out the false positives. Okay. So when you use AutoML, then you're using your own samples. That's what it's learning.
Okay.
Yes.
There are some case studies around the New York Times using some of these to identify images.
Yeah.
Is it using this service in the cloud, Google Cloud?
Yeah. No, I didn't quite get the whole question.
I was just reading about the New York Times having a big repository of images and pictures and photos that they're providing new insights into. Is it somewhat using some of the cloud services that
I'm not familiar with what the New York Times is doing, but it sounds like they're using some Vision API service, whether it's from Google or another company.
How is this charged? What's the pricing?
Oh, I'll have to. I would suggest going online. It's. I can't remember if it's charged by the 1,000 or by the million API invocations. Yeah, but it's in the same pricing range as its competitors.
What other products does Google have in this category of AI beyond the AI as a service and machine learning as a service?
Well, all of its other products, I would say, are geared towards data scientists. So that's more in the premium realm. So. Any other question? All right. Probably a great time. The other thing is, people still want to dabble into learning models and making models. And if you're doing that for the first time, I'd encourage you to use the Keras framework. So that's an open source framework supported by Google. That framework was specifically designed for software engineers.
And for TensorFlow?
TensorFlow, you need to be a data scientist to really effectively use it. It's a computational graph. You're doing symbolic programming. You need to know your statistics. Keras is an OOP abstraction on top of TensorFlow.
Sure. Okay.
Yeah, you can't do everything you can do in TensorFlow, but you're just learning, right?
Yeah.
You don't need that fine level. Yes.
You mentioned something at the beginning about the live text or speaking transcription.
Oh, yeah, speech to text.
Is that baked into AutoML or is that?
Oh, well, okay, that is part of just the API service itself.
Okay.
So you can hook up, you could send an audio clip and get back the conversion, or you can actually set up a live stream and get real-time transcription.
Interesting. Have you compared that with AWS's transcribe service?
I have not.
It's really interesting.
Thank you. So I hope you guys enjoyed this approach. That wasn't really marketing.
This is awesome.